What's up, pussies? Blood Nation, let's go! It's the motherfucking podcast. And let's just get right on into it. Doing a bit of chemistry. And then, maybe learning about TikTok ads. Turns out we can now do TikTok ads in New Zealand, which is pretty litty. Just gonna check my emails real quick, and then we'll get right on into it. Hey. Okay. Go wait. Go wait. The fuck? Alright. I'm getting some money from my Shopify. That's nice. Okay, let's do some chemistry work. Here comes the money. Yo! Yo! Papa!
Good night.
How's it?
I just want to see if there is a way we can...
What are you looking at under there?
Did you have hot water in your shower this morning, Claire?
It was weird, man. It was like
Just lukewarm.
it was like the water went really hot, then cold, and then hot, then cold.
Yeah, they had to come again to... We didn't have any by the time we got up.
It was really odd. It was like it kept on going from hot to cold.
Yeah, it's something to do with the flu and the gas not being able to get through or something.
The flu. You've got the flu.
The flu up on the roof. It's cool. We had this discussion the other day. I was trying to tell you about the parts of a chimney. Well, there's a flue for the gas to go out. We're trying to see how we
Did
can...
we always have this?
Yeah, that's the bit he broke off.
But there must be something
Sorry.
else. Surely.
Well, now we can't change the temperature. We just have to have it really hot when we turn the heaters on. Sorry.
What? I like my room cold though.
We never used to do that.
Well, it didn't used to work as well.
Must
So
just be
you
that
don't have
much-
work tomorrow, Flynn?
Nah.
Damn.
What? Why did you say that?
I was this morning looking forward to,
Yeah.
having no one at home and just having peace and quiet, and then Star Plumbing had to come back.
Unlucky.
Yeah, well,
Oh, because I look at it, you'll probably be able to fix it.
No, you won't be able to fix it, but you might be able to adjust the heater by turning that nut.
Oh yeah, let's get a wrench.
This probably just turns that nut, but who knows?
Oh, is it circular or not? Oh yeah, let's get a wrench. I've got a little adjustable wrench. They call it a crescent.
You'll need an actual socket in there.
Yeah,
Because
right.
there's no... Even then it doesn't... It'll be like...
Let's get the sockets in there, boy.
What does it? What's that?
What are you doing? Why are you always bending down?
house, open house, board. Board in the house, open house, board.
No, I don't. I'm not sure that it is that it turns.
What?
I was just looking when you turn the other one. It's only this that you turn. Maybe that does.
Yeah, no, it does. The whole
Does it
thing
not?
is that next to that, and then you turn this,
Does it
and
not
then it
then?
turns that.
How does it connect to that?
Fiddle with what you don't know, because I'm not bringing them to get them back. If you always balls that up, you're in charge.
I'm just considering the way. Are you actually looking at the numbers and then seeing if you need to go bigger or smaller?
No, I'm just grabbing this.
Like
It's
random?
the same size. Not at random, it's like
Have a look. Which is one that's near, and then you look and you see if you need bigger or smaller.
I'm just going through all the ones that are like the same size. 'Cause it's just too big or just too small.
You need to actually read the numbers.
Yeah, I reckon you're right.
This one that's close.
Alright, that one's close.
No?
Yes.
No, it has to go right around that whole nut. What do you think it's going to turn?
Oh my god, I am silly.
You just step out of the way.
Let's go back to my original strategy.
It might not even turn it. That might actually just go inside it. Is it kind of a? Can you have a look?
Does that fit? Or is that slightly too big?
I want to have a look to see. That might not even be what you turn, because that might be pushed down inside the.
Is it too small? It's too small.
Yeah, it's bigger. And this is a 11, so you need to find a 12.
11. Nah. Alright, 11 is probably the right size because 12 is too big.
No, this is 11.
Yeah, this is 12.
Is it?
That's 11. This is 12. See how it says 12?
Yeah.
I put it on. That's so weird. Why is this one? This is a 12 and 12, which is way too big.
Look. Just see there's a long 11 because that. Is that 11?
Yep.
Does it fit? Look. Look at that. I think it is a 12, but there's not enough room between the. For it to fit between the plastic and the thing.
What?
You know what I mean? It's just hitting the edge.
Let's try the small one.
Oh, there it is.
Ah, you? Good on this one.
Hang on, I'm just twisting my hand.
It's actually supposed to be there. Oh yeah. Yeah, it wouldn't take much force, eh?
But do you want it turned right off?
Just turn it down.
We have to guess because you don't know.
Doesn't it click into place though? It clicks
No,
into place.
it doesn't. It just. So when you screw it down,
Oh yeah. So when it goes all the way down to
clockwise,
0.
that's 0, and then when you screw it up,
Yeah. Well, let's keep on going. You were going left there.
no, it's clockwise to make it. If you were turning it down, you do it clockwise.
I'll go to 0.
But you might not know that might. It doesn't mean that will stop. So you might be careful because you might damage it if you spin it too far.
What do you mean?
What I mean is this stops like that when it hits that.
Oh,
But if
yeah.
you're just turning the nut, you might be actually turning it further than that, and it
Yeah.
might damage it.
Yeah, because it could be.
Just leave it like that, and then when we turn the heaters on, you'll see.
Yeah, because that just hits something, doesn't it? Yeah, because it's.
And if we're turning the thing below that, and it'll be like you're turning it too far.
Yeah.
But just leave it like that, and just leave it on there, and then you can use that
well.
to turn it.
Yeah, I'll go a bit so it's clockwise there, so.
Clockwise turns it makes it colder,
So
and anti-clockwise makes it warmer.
So I want warmer. Yep. I'll go a little bit warmer and then we'll see. I'll just keep that. We'll just keep that there, right?
Yeah.
Right, can I turn my heaters on?
Yeah.
Oh, this one might explode though.
Well, it might.
Really?
You boys fiddling around. Hey, stuff you don't really know about, all the all leak out.
Oh, was this supposed to be? Definitely opened that the wrong way. Let's hope to God if I just quickly
No, did you
close
tip it upside down and then open it?
It was already messed when I opened it there. Alright, let's put everything back in place in this first.
Have you turned them on?
Gotta say hi all the time. What the hell? What the?
But did they bring you letters as far as they're That's a bit silly to warm up.
I'm not shoving them where they're supposed to go, just wherever they fit. often do you use the socket saver?
How much does it cost you?
Someone gave it to me.
Strap them wherever you can. What the hell goes in there?
This goes.
What the hell is this guy?
Yeah. This will go like here somewhere, right? I actually could.
That goes in here. Looks like another socket.
Might even be better if on a different one.
Amazing.
Alright. Shimmy, 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 fuck. Let's do some chemistry work, huh? This is an electrolysis reaction. Pretty simple shit. Bubble of pale, shiny grey molten metallic calcium is produced at the other electrode. Molten metallic calcium state. Molten makes me think it's liquid. Let's define molten. I am fucking hungry. Define molten. Yeah, liquefied, so that's liquid. CAL is being produced at one end, and at the other end, CAL, and at the other end, CLG. Positive E naught value, that means it has the tendency to be reduced, which means it gains electrons, which means it should be going into Cl liquid, but instead it goes into Cl gaseous. Okay. What I'm gonna do in the face. I don't care if they do, put the boobs in my face, yeah. Knickknacks wanna be like me, okay. Calcium solid becomes calcium liquid. That has the tendency. The tendency to reduce, but instead it's not being reduced. Yo! How hot is it?
Still feels really hot. This might not even be doing anything.
What do you mean it's not doing anything? Let's turn it down.
I think also when you adjust it, you then have to wait for ages before it takes effect because it's hot anyway.
It's hot as shit. Yeah, we'll wait like.
We should do that.
Nah, let's just wait. Chill. We'll just wait like 10-15 minutes.
No, we'll be more like half an hour or something.
You're the boss man. Let's see how hot that is.
But what's this like? Oh, it's on fire.
What's the date? Oh, do you want to buy this one? I'll sell it to you for $50.
No, I'll just keep it for all the
I'm not talking to you.
Don't do
I'm not talking to you.
no chores.
I'll sell it to you for $50.
Why don't you just go there and buy like some bacon and eggs and things and whatever?
Alright, $40. I just want to make more this.
You got next year, you need it.
Sometimes instead of sending me texts, I just record my voice. There's enough for us. No, you don't. My back's sore, my neck's sore. I know.
Alright, maybe we'll finally do some chemistry work, eh? Maybe we will finally do some chemistry work. If you guys don't have an vested interest in me, holy fuck, there is no point in watching this. It's like I just fuck off for like 10 minutes and then I just like sit down and talk to my old man for like 10 minutes. Like seriously, if you guys, this will have no, most likely it'll be like close family maybe. Even if I do have I won't have, like, even if I have a business, no one's gonna give a fuck about that. No one's gonna give enough of a fuck to watch me fucking putting a socket on a fucking heater for 10 minutes. Alright, let's do some work though. I'm trying to fucking think about this, eh? What are we doing? How is it not that? Chlorine gas is being produced. Well, alright. But chlorine gas is being produced. But it has a tendency to become chlorine liquid. But it's sending electrodes down there. It must be taking electrons away. Right. Which is what an electrolysis cell is. You dumbass. Right. Alright, fuck it, let's watch a video on this. All I remember is that if the E0 value is negative, then it's electrolysis. But that one is positive. Example. Man, I am fucking hungry though, eh?
Let's talk about the chemical process of electrolysis. I wanted to change electricity to make that chemical change happen.
Get it.
Now, electrons, it's being oxidized from -1 to 0. Liquid, melted sodium chloride. Sodium chloride doesn't melt until about 1500 degrees Fahrenheit or 800 degrees Celsius. So it's got to be super, super hot. And this device has to withstand really high temperatures. The sodium chloride has got to be molten that electrons move. Electrons move from here into the battery and then out of the battery. Final equation for the electrolysis of sodium chloride. This happens because sodium gains electrons and is reduced. This happens at the cathode in the electrolytic cell, which pushes out electrons. It's where reduction takes place. And it's where sodium gains these electrons. Here is the half reaction for the reduction of sodium. Then chloride loses electrons. It undergoes oxidation, and this happens at the anode in the electrolytic cell. The anode pulls in electrons, oxidation happens there, and here is the half reaction for chloride losing electrons and getting oxidized. So that's how sodium chloride turns into sodium and chlorine gas during electrolysis. Here's another super common example, the electrolysis of water. We take water, H2O.
Are we going to see E0 values?
Now, I should say this electrolysis process doesn't just happen in distilled pure water. We got to add polyatomic ions, are called molecules of 4 electrons, and put it.
That's been 5 minutes. Oh my god.
Electrolysis is electrical current flow through a liquid which causes chemical changes. Yes, you did hear that correctly. Current flowing through a liquid. Now, not all liquids can conduct. The liquid can be a molten ionic compound or an aqueous solution.
Hey, that's what
In either case, it must be able to carry current. Let's take a common example, table salt. If you heat sodium chloride to over 801 degrees Celsius, it will melt. The liquid will contain free-flowing positive sodium ions and negative chloride ions. This simply means that sodium and chloride ions are free to move within the liquid sodium chloride. Positive ions are called cations. Negative ions are called anions. Now, consider putting 2 electrical conductors into the liquid. Copper would be good, as it has a higher melting point. Nothing happens to the ions at this point, but if we connect the 2 bits of copper to an electrical cell or power supply, then things start to get interesting. We do need to sidestep for a moment to look at electrical current in a metal. From our lesson, Behavior of Metallic Structures, we know that electrons in a metal aren't bound to particular atoms.
Talk about E0
They form a
values,
sea of electrons that can move easily if a potential difference or a voltage is applied across it.
Here we go.
Before we get into electrolysis, let's review the structure of a voltaic cell so we can compare it to an electrolytic cell. So a voltaic 0.10 volts. Remember, a positive value for your cell potential means a spontaneous reaction. So we produce an electric current. Let's compare that voltaic cell to an electrolytic cell, so on the right. An electrolytic cell uses an electric current to drive a non-spontaneous redox reaction. So if we look at the overall reaction here, we're starting with solid copper and zinc 2+ ions in solution, and we're going to copper 2+ ions in solution and solid zinc. So this is the reverse of the reaction we just talked about, right? The reactants for this reaction were the products for this reaction. To find the standard cell potential, all we have to do is take the negative of this cell potential because we just reversed the reaction, right? So if we reverse the reaction, we just change the sign. So the cell potential, the standard cell potential would be negative 1.10 volts. A negative value for your cell potential means a non-spontaneous redox reaction. So this doesn't occur on its own. Solid copper doesn't just turn into copper 2+, and zinc 2+ doesn't turn into solid zinc. It needs some help in order to do that. It needs an external voltage source, like a battery, to drive this reaction and force it to happen. So we need a battery here. Let's put in a battery in our little circuit. So we have a battery. We need the negative terminal to be on the left side and the positive terminal to be on the right side. So this is our voltage source. And we need at least 1.10 volts to force this reaction to occur. And in practice, it turns out to be more than 1.10 volts. So our negative terminal of the battery is where we get electrons. So electrons come out of the negative terminal of the battery, right, and deliver electrons to the zinc electrode. So electrons are forced onto the zinc electrodes. Let me draw in here 2 electrons. And now we have zinc 2+ ions in solution. Those zinc 2+ ions have an opportunity to be reduced. If those zinc 2+ ions gain those 2 electrons, zinc 2+ gains 2 electrons and turns into solid zinc. So solid zinc forms on our zinc electrode. So zinc 2+ gaining 2 electrons to form solid zinc is reduction. Gain of electrons is reduction. So this time, reduction is occurring at our zinc electrode, and reduction occurs at the cathode. So the zinc electrode is our cathode. So once again, red cat. The zinc electrode is more negative, right? So we've had electrons forced onto the zinc electrode. That makes this our negative electrode. The battery is pulling electrons away from the copper electrode. So the copper electrode is losing electrons. So electrons are going toward the battery here. So electrons are going toward the positive terminal of the battery. That makes the copper electrode relatively positive. So this is our positive electrode. And this must be the site of oxidation. Right, so solid copper turns into copper 2+ ions. So solid copper turns into copper 2+ ions. So we have solid copper turning into Cu2+. And so we're losing 2 electrons in order to do that. So solid copper turns into copper 2+. We lose 2 electrons. Loss of electrons is oxidation. So oxidation occurs at our copper electrode this time. And that makes this the anode because oxidation occurs at the anode, so anox. So the copper electrode loses mass over time. So you can see the difference between a voltaic cell and an electrolytic cell. Yep. So a voltaic cell created a current because we had a spontaneous redox reaction. But for
Yeah, but still in this one, it seems like... .8 volts. Wait. Oh, yeah. Yeah, 2.8 volts are being gained from the calcium. That is its tendency to reduce to gain electrons. That is negative. So it's actually more likely to lose electrons. More likely to get a calcium solid to calcium liquid. Right. But E naught is still positive. How could E naught even be negative? Right, fuck it, we're just gonna... molten calcium chloride. Just gonna put on this reaction into YouTube.
आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी।
Wrong language, but it actually is what I want.
बायोलॉजी डाउट्स का सफाया।
Fuck, it's a rough fucking equation. Could you just not speak fucking
अपने क्वेश्चन की फोटो खींचो। उसे क्रॉस।
तो यहाँ पर हमसे पूछ रहा है क्लोराइड, कैल्शियम क्लोराइड क्या होता है CaCl2 और राइट माइनस यही मिलेगा। तो अगर मैं एनोडेशन होता है क्या तो कैल्शियम सी फर्स्ट हमें दिया कैल्शियम, सेकंड दिया फास्फोरस।
Let's not watch that. Oh, this guy again. Who the fuck is this guy?
This lesson looks at examples of molten ionic compounds and how they can be used in electrolysis. Before going any further, you'll need to know what electrolysis is, and you may wish to refer to our lesson, What Happens in Electrolysis. Ionic compounds are formed by the strong electrostatic bonds between positive and negative ions. The oppositely charged ions are locked into a rigid and regular structure. And since the ions are fixed in position and aren't free moving, an ionic solid cannot conduct electricity or undergo electrolysis. But one way of making it conduct is to heat it until it melts. In our examples here, the cations or positive ions are all metals, but it's worth noting that hydrogen can also be a cation in an ionic compound.
Yo.
Well, we're going to look at molten sodium chloride. The ions are a sodium cation and a chloride anion. Sodium ions will be attracted to the negative electrode, the cathode, where they combine with electrons to give sodium atoms. This is a reduction reaction. Each ion gains one electron and sodium metal is produced. At the anode, or positive electrode, the chloride ions will each give up an electron and become a neutral chlorine atom. This is an oxidation reaction. The single chlorine atoms then pair up to form chlorine molecules and chlorine gas is produced. Overall, the electrolysis has split the molten sodium chloride into its elements, sodium and chlorine.
Oh, that guy's fucking bugging
This is how sodium and chlorine are produced industrially. The electrodes themselves are usually made from an inert material such as carbon.
Shut
When
up.
it is heated and melts, it becomes atoms. The bromine. Now, if you were to do this in a laboratory, you'd see silvery lead forming on the cathode and a brown gas being given off at the anode. This is bromine.
Alright, stop watching that. Fuck it, I don't need YouTube. Okay. To tell if... Whoa, you're fucking going fast. I must have fucking won with them. Is spontaneous A that popped up. Alright. Pull bones.
Hey guys, Michael from Carb Chemistry. In today's video, we'll be talking about how to determine if a redox reaction is spontaneous or not.
Alright.
And to do so, you just need to look at the cell potential, or the E cell, And if the E cell is positive, then it'll be spontaneous, and if it's negative, it'll be non-spontaneous. So spontaneous just means that the reaction will happen without outside help. It will happen naturally. Let's take a look at how to determine if these reactions are spontaneous or not. The first thing we have to do is determine the cell potential. And there's two techniques. I'll show you one technique for the first reaction, and then the second technique for the second reaction. Let's start with the first reaction. The first technique for calculating the E cell is just to split the reaction into two half reactions. So we're going to split the reaction by putting the ZNs in one reaction and then the CUs in the other reaction. Then we're going to balance the reaction by adding electrons. So there's 0 charge on this side, positive 2 charge on this side, so add 2 electrons over here, positive 2 charge on this side, and no charge on this side, so add 2 electrons over here. So now both sides have the same charge. That's 0 on both sides here, 0 on both sides here. Then we take a look at the voltage for each of these half reactions. So this one would be an oxidation reaction because the electrons are being lost. Electrons are on the product side. And then this one is a reduction reaction because the electrons are on the left-hand side, which means electrons are being gained. Then we look at the cell potentials. So Zn is, where is Zn? Zn's over here, but these are reduction half reactions. So Zn here is oxidation. That means we need to flip the voltage because when you flip the reaction, the voltage is flipped. When you flip the reaction, a reduction reaction becomes an oxidation reaction. So then this will become 0.76 volts now because we flipped the sign.
Yep, so 2.84.
And then the next one is this reaction right here. And this is a reduction reaction. That's a reduction reaction, so we can just keep its voltage of 0.34. Then we add the two...
Needed 1.36.
The two voltage together, and we get the total voltage of 1.110 volts. And since this voltage is positive, it means this reaction is spontaneous.
But that E naught is positive, isn't it? Oh, what the fuck? Oh. Oh, show me. That is reduction as it gains electrons. You stupid dumb idiot. Right. Right, but it's doing it the other way around.
It's going to happen without outside help. Then the next one. So the second technique is to use the equation E.
Let's just do the whole equation so I can just figure some shit out. Right. That made sense, don't it? Full reaction. Bless me. Bless up. Okay. CL minus L plus shoe. But those charges are not balanced. Come on, you give me the answer. Fuck off, I don't want a free account. See the answer. Alright. BR minus. Sir, there is no BR minus. BRB. Right, okay. That's what we're doing now, I guess. CaCl. 2 liquid. Goes into Ca solid plus Cl2 plus Cl2 gas. Right you are. Okay. Oh, okay. Right. So I was actually wrong. It's actually a solid that's being produced. That's what I got wrong. I thought molten meant fucking... Oh, whatever. Whatever. This isn't in the tins. Alright, I finally got it. I'm going to answer this question and then hand in the TA. First, I'm going to get some food, eh? You guys want something? Oh, wait, you guys are on a laptop.
You pretty clear and stuff? Yes, sir. You feel how hot your heater is now. It's really hot. Maybe this isn't actually turning it down. Even the socket's hot.
Which way is it again? Left or right?
Clockwise to the right.
So turn it down.
But it's not, like I said, it's not an instantaneous thing. Now you wait half an hour to see if it seems that it is hot.
La 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 la. This is a really good podcast, though. Right, let's finally answer this question. Calcium ion. However, it's being reduced. Reduction reaction. That's primarily which is non meaning the half reaction is non-spontaneous. Cathode. I guess it's the other way around. Yeah. The anode end. Cl is oxidized. Pardon me. Gaseous chloride ion. The tendency for fluoride is to reduce Sure. However, it's an oxidation reaction. non-spontaneous. Just for you choose oxidation reduction reactions using oxidation numbers and electron transfer. Alright, enough fucking breaks, eh? Let's fucking finish this. Jesus Christ. An hour and 12 where it's like 40 minutes of me just doing nothing. Done one question in an hour and 12 minutes. And I've done fucking less than 2 paragraphs. Means the voltage is in. Battery supplies this voltage. Right, this makes complete sense now. Static forces to pull electrons. Instead of Do 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 boo doo doo boo doo doo boo doo doo. Oh wait. The solid's being formed now. What would that be? Supplying electrons to the many cells are being primary. Yes. This results in awesome. Control C. Taking electrons from meaning instead of this shit being primarily formed. Yes! Finally understand. Positive. Oh wait, fuck. Right, it's not actually. From CAS. through. Right. To form. Yes. Yo. No, man. Being produced at the electrode. That's easy, so much. I'm doing some weird ass burps today, you guys. If you're interested. Right, cool. Fuck me, I'm finally done. Cool beans. Alright, that screen's frozen. Alright, this is me done. Peace. Peace.